Hey y'all. Hopefully y'all are doing well today. As you can see, I'm still actually at school when I'm recording this video. Um, so I know that we won't be seeing each other on Wednesday because of iReady. So instead of waiting until the next time we meet, I figured that we would actually use a video to go over the next lesson that was planned for that day. So I'm actually going to share my screen and I'm going to share a set of the notes that we would have covered for lesson four. So we're going to do that today. And then that way, when I see you all next week, we can go straight into lesson five. So let me go ahead and share. All right. So hopefully you all see what I see, which is my doc cam, and we're going to be looking at lesson four, which is describing quantitative data. Now, in the last lesson, when we talked on yesterday or on Monday, we looked at categorical data, where we looked at different ways that we can visualize that. We looked at segmented bar charts, mosaic plots, regular bar graphs, and talked about like the differences between them. So for today, we're going to be looking at an example of how we're going to graph quantitative data. And how we start that is by doing this activity about how many pairs of shoes do we own. Now, normally in class, we'd be doing this and I'd be asking us to share how many pairs of shoes that you would have. Some people might be saying five, some people might be saying all the way up to 100. But I actually went around today and asked a few teachers after school, and I asked them how many, excuse me, I asked them how many pairs of Nikes that they own. Not asking about Jordans, I'm asking just specifically Nikes. Okay. And I have all this data that I wanted to give you. So we had some people say five, five, five. These are all responses I'm giving. Six, eight, nine. Um, we had four people say 10. One person said 12. One person said, or excuse me, two people said 15. One person said 20. We had a 25, and we had one that said 40. So this teacher had quite a few Nikes on them. So what we're going to do is that we're going to take this information here, and then we're going to answer some of these questions at the top of page 13 of our packet. All right. I'm actually going to bring the data over here just to the side because we will be using this momentarily. But I want us to go ahead and answer questions one and two. So I want you to take just 1 minute. I want you to answer these two questions here on the top of page 13 and go ahead and pause this video now. And that way, when we come back, I will have the answers already prepared for you. All right, we're back. So for question one, is number of pair of shoes categorical or quantitative? You should have said quantitative. And the reason for that, simply put, is because all of our responses are number values. And so for the second question, where it's saying, can this variable have decimal values? In this context, no, does not make sense to have zero point 0.2 of a sneaker. All right. So this is kind of leading towards two types of quantitative data that we could potentially have. The first option is that we can have what is called discrete variables. And if you have discrete variables, that means that you have no decimals in your values. So like in this context, we have discrete values. That means we have discrete variables. If we were to have decimals within our answers, then what we would have is that we would have what is called continuous variables. And that is where, again, decimals are okay. All right, so now what I want to do is that I want to take this information that we recorded from teachers and I want to create a dot plot of our findings. Now remember, with dot plots, I'm going to move this down here slightly. It does make sense that considering what our data looks like, and then if we have to label our own axes, we can go however far we want to go, meaning that we can do this by 10s, 15s, 20s. For this context here, and based on our data, I'm just going to have our number line go by 5s. So I'm going to start at 0. So we're going to go 5, 10, 15, so on and so forth. And I'll stop at 45. So we're going to record all these dots here. So we got 3 5s. We have a 6. So I'm going to label this dot here as 6, since obviously it's between 5 and 10 and closer to 5. I'm going to have a dot that represents 8, a dot that represents 9. And then I'm going to have 4 dots for 10. I'm going to have a dot for 12, so maybe like right there. 2 dots for 15, a dot for 20, a dot for 25, and a dot all the way over here at 40. So this is going to be the dot plot that corresponds to this data here that we have for number of pairs of Nikes that teachers own. So that is one way we can actually visualize quantitative data. The second option is that we're going to look at this on the left here. The second option is what we have called a stem and leaf plot. Now, sometimes, yes, we call them stem and leaf plots, but another word that we might use is just stem plot. So if you hear that, we're referring to this. All right, so for a stem and leaf plot, what we're doing is that we're going to have a side of what we call other side for what we call leaves. My apologies for that. I'm going to go ahead and go back to sharing. Okay, so how this works is that these numbers here on the left of this vertical line, these are what we call, these numbers here, these are what we call stems. Think of these as like the 10th or the 10 digit. So like if I wanted to write the number 5, we start with a 0, and then we're going to write the number 5. And since we had 3 dots to represent 5, I'm going to write this 3 times. Then we had a dot for 6, a dot for 8, and a dot for 9. Okay, now, if I want to represent the number 10, what I do is that, well, the stem is 1 and the leaf is 0. That's like your ones digit, okay? So instead of writing 10 4 times, we're just going to write 0 4 times, and this represents the number 10. Then my next dot is 12, so the next number I should write after that is 2. Then I'm going to write 5 2 times because we have 2 numbers for 15 or 2 dots for 15. And that's it for this row. Now, if I'm moving in my 20s, well, I have a 20 and I have a 25. So that means that the leaves that go along with this row here should be 0 and 5. Now, note here in our dot plot or in our data, we have no numbers between 30 and 40. So that means that for our stem and leaf plot, we're going to have a gap here. Okay, so we're just going to leave that row blank because, again, we have no numbers in our data between 30 and 40. And because I do have a dot all the way here at the end at 40, that means that I'm going to have a leaf here with a number 0, and that again represents 40. All right, so all these numbers on the left are what we call stems, and all these numbers here on the right that I'm boxing in right now, these are what we call leaves. Now, I'm gonna be 100% honest with you. I am not a fan of stem and leaf plots, but it is something that we must know, especially for the AP exam, because they're going to be asking you to visualize data with stem and leaf plots, or they might give you a problem where you have a stem and leaf plot and you have to uncover what it is that they're looking at. Okay. Now, the other thing that is important for stem and leaf plots is that you need what is called an answer key to help anybody who's looking at one kind of visualize what it represents. So in this case here, if I have a stem of 4 and a leaf of 0, that represents the number 40. So for a key, you only have to do this once where you're just showing an example of what one of these numbers represents. So you don't have to do it multiple times. Okay, so that's the second way that we can look at visualizing quantitative data. The last way that we can look at visualizing this is using something that is called a histogram. Okay, so how that works, similar to like the dot plot, we're going to have a number line here at the bottom of our, you can call it x-axis if you want to. I'm going to try to use the same numbers as I did in my dot plot above here. So what I'm going to do is that I'm going to do 0, 10, 20. I'm just going to skip for now, 30, 40. And I'm actually going to go all the way up in this case to 50. So I'm going to add a little bit to my line. Okay, so I'm going to go all the way up to 50. Now, how this works is that we are going to be looking at, if you want to use the data here or the dot plot, we're going to be kind of grouping our numbers together. So in this case here, we're going to create, like, you can call it a bar graph if you want to, but it's slightly different, and we'll talk about that in a minute. But we're going to be creating a bar graph almost that shows how many data points or how many dots we see here in a certain range or in a certain interval. So if I'm trying to look at 0 up to 10, I'm trying to figure out how many dots or how many points of data we have from 0 to 10. So less than 10. So if I count these out, I have 1, 2, 3, 4, 5, 6. So I'm going to create a bar here, and I should label this too. We're going to go, we're just going by ones here. So we're going to have this first bar go all the way up to 6. Okay. And again, what this represents is that this is the number of data points from, so this is the number of data points from 0 up to 10. So we had 6. Now I want to look at how many numbers do we have starting at 10 going up to 20. So we count our data points here. I'm including tens here. So we have 1, 2, 3, 4, 5, 6, 7. So I have 7 numbers starting at 10 going up to 20. So my second bar is that from 10 to 20, I'm going all the way up to 7 for this second shape or for the second bar. Okay, note here that when I've created my 2 bars for a histogram, there is no spaces between them. Okay, not only that, with us creating this bar here from 10 to 20, we included the 4 tens from our data. So it's going to be important that when you're creating a histogram, all right, I know sometimes if we're looking at this bar from 0 to 10, we might have put these inside this first one. No, you have to be careful about that. These tens are actually going to be in the 10 to 20 range because we're starting from this number, including it, and we're taking everything up to this number, not including it. Okay, so that means that if I were to look at creating a bar from 10 to 30, I'm including the number 20 and any other number that is less than 30. So in this case here, I have 2 numbers, 20 and 25. So that means that my third bar here is going to go all the way up to 2. And again, we're having no space between our bars here for a histogram. Now, we had no numbers in our data between 30 and 40. So we're going to have a gap right here inside of our histogram. And then we have one data point or one number left, 40. So we're going to create a small bar here at the end that goes up to 1 because we have 1 point that starts at 40 and is in between or less than 50. So this is our completed histogram for this data here. I'm going to move this up here because we won't need that anymore. All right. So now what we want to do is that we want to take this data that we have here and we want to answer some questions here at the bottom of the page. All right. So if we look at question 4, how many pairs of shoes does the typical student, or in this case, the typical teacher, have? Well, based on our data here, we're going to say maybe about 10. And that should kind of make sense because if we look at the dot plot, for example, not only do we have a lot of people who said 10, but it looks like that's kind of like our highest point, or that's kind of probably be like where our median is going to be. And we'll talk about median later on in the unit. Now, for question 5, this is kind of getting into the nitty-gritty of this lesson. We're looking at what is describing the distribution. All right, so this is a big part in AP statistics, where a question might ask you to describe the distribution. All right, so if you get a problem like this, there are 4 components that you need to include in your response if you're given this question. We call this abbreviation SOCV. So SOCV, where each one of these letters represents something. If you're asked to describe the distribution, you need to include the shape, or talked about the shape. You need to talk about any what are called outliers. You need to talk about the center of your data, and you need to talk about the variability. And the last thing that I'll include that you also should include is context. So what do I mean by context? Well, what are we talking about in this example here? In this problem, we are talking about the number of shoes, okay, or pairs of shoes. So this is your context. So any numbers we talk about or any if we're talking about the shape, we need to make sure that we include, well, what is it that this data is collecting, or what is it that we're talking about, which in this case is number of shoes. So you have to include that information in your description. All right, so let's talk about shape. First thing first. All right, if you look at the graph here, whether it's the histogram or the dot plot, what you might notice is that we have a lot of numbers here that are kind of on the low end, okay? And we do have a few numbers that are on the high end, like 40, all right? So we're going to include that as part of our description. So we're going to say here, most of the values are low with a few at the high end. Okay. Now, if you have something like this where you have a lot of numbers or a lot of your data is on the low side of your number line, what you will have in terms of your shape is that you're going to have what is called a skewed, spelled that wrong, a skewed right. So not only is this a skewed right distribution because most of our numbers are on the left side, and we have a couple of these high end numbers on the right side. That's why it's called skewed right. So we got a couple of numbers way on the right side. We also have what is called a unimodal distribution. And what that means is that we really just have one giant peak in our graph. And that should make sense because our giant peak here is around 10. So we have that. And we should also mention that we had a gap in our graph or in our data between 30 and 40. Now, again, as I mentioned before, it is important that we're talking about context. So if you were to write this on your own and you're saying this is skewed right, unimodal, and there's a gap between 30 and 40, well, make sure you include the context. It's between 30 and 40 pairs of shoes. Okay. This is how you get full credit for an open or free response question. This is what they like. All right, so that's shape. Next thing, outliers. So we'll give a more formal definition of an outlier later in the unit. But basically, what an outlier is that if we were to look at our data, is there a point or are there a few points on either side of our graph where they're kind of far away from where most of our data is located? So in this case here, most of our data is probably in this space here between 5 and 20. So what you might say is that potentially 40 could be an outlier. So we're going to write that here. So we're going to say 40 is a possible outlier. Okay. Now, the next thing we're going to talk about is the center. So first things first, when you're talking about center, you typically want to figure out what is the mean and what is the median of your data. Now, most of us already know, or maybe more so than less, mean is nothing but the average. So we're just trying to figure out what is the average number of, in this context, shoes that a teacher would have. So for the meantime, or for right now, I'm going to actually give you that information, what the mean is. The mean in this case is 12.8. So that's the average. And we'll talk about later in the unit how you can actually find that through Desmos. The second thing that you will need is the median. All right. And the median in this case, which is the middle number, it actually turns out to be the number 10. So you have a median of 12.8 and you have a median of 10. We have one center. And the question is, which number do we choose? Do we choose the mean or we choose the median? Well, it all depends on the shape in terms of which one you go with. So I'm going to write you a note here. If the shape is symmetric, you will use your mean as the center. If the shape is skewed, then what that means is that you're going to use the median as your center. So because of this case here and looking at what we have from our data, we said that our shape is skewed right. So because it is skewed, that means that our center, we're actually going to use the median, which is 10. And that should make sense because if we try to use the mean, well, because we have this huge number of 40 here, that's pushing our average or our number to go up when really most of our data is very close to 10. So that's why we choose the median instead. All right. And then the last thing we need to talk about is variability, AKA spread. All right. Now, our variability is like we're looking at where our data is coming from in terms of min and max. So if we look at our data, the min number of shoes that a teacher had was 5, and the largest number of Nikes that a teacher had was 40. So our variability here, we're going to say, is from 5 to 40. Now, not only can you say that, but you can use what is called the range. Now, how you find the range is that you take your max answer or your max minus your min. So the highest number we had is 40. The smallest number we had is 5. So 40 minus 5 is 35. That is your range. Typically, with AP exam graders, they want your range to be a number, not an interval. Okay. So if I'm using range, I need to see a number. And again, context wise, 35, we're talking about shoes or pairs of shoes. So make sure you include that as part of your response. Now, question 6 is asking which of these three types of display do you prefer? I leave it up to you to decide. Maybe you like a dot plot, but if you had a large number of data points, dot plots are probably not going to be your best friend, especially if you have thousands of data points. You don't want to do 1,000 dots here. So maybe on the smaller side, dot plots are better for you. And maybe when you have a larger number of data points, maybe you go with a histogram because you're just kind of grouping your responses together. Okay. And still, it would give you a good idea of what your data is going to look like overall. So I know we just did a lot in this on this page, but we're going to still summarize everything that we just did on the next page. So I'm going to go ahead and move to page 14 at this point, where we're going to hit some quick notes here at the top of the page. All righty. So there's really going to be two things that we talk about in our quick notes for today, and these go to the two aims or objectives of the lessons, which you can find on page 2 of your binder. So the first thing that we're going to talk about or recap again is about quantitative data. And we said that there's two types of quantitative data you can have. You can have what's called discrete, where again, this is where you have no decimals in your numerical values. Or in other words, we sometimes say countable, like 1, 2, 3, 4, 5, like counting numbers. The other option you can have, it is what's called continuous. And that is where your numerical values could be decimals. And for this reason, you can have an infinite number of responses. So if I were to ask you how many numbers are between 1 and 2, and we're including decimals, well, there's so many different decimals between 1 and 2, like 1.1, 1.11, 1.111, so on and so forth. So there's an infinite number of decimals that you can have between just 1 and 2. So we have quantitative data. We've broken down into two different options. And we've also looked at different ways on how we can visualize this data. Well, first option was using dot plots and stem plots. And these might be nice because these can show individual, so like every individual value. So if you want to see every single response, dot plots and stem plots might be the one that you want to go with. Whereas if you have a large set of data and you don't necessarily want that, then probably a histogram is the way to go. So histograms just kind of show general shapes. It'll give you the right idea of what's happening with your data, and you can go from there. Now, we kind of touched on this with our activity from the last page in terms of shapes of graphs, but I'm going to put all the different options in our notes here. All right, the first option which we saw is where you can have what is called a skew right shape. So you're going to have all your data kind of on one side, and you have this tail on the right side of your graph. So skewed right. Now, if all of your data is over here on the right side and you have your tail on the left, this is what we call skewed left. Now, if we have a shape of a graph that is pretty much right down the middle, if I cut it in half and I get two equal parts, this is where we have symmetric. And excuse me if you can't see that, but again, this is called symmetric. Well, we saw what is called a unimodal shape, which is where you have one peak. So all of these are unimodal graphs because we have one peak here. But you could potentially have a graph that has two peaks or like two mountains. And if that happens, you have what is called a bimodal graph. So that's our first point from this data or from our lesson for today. The second one is where I was kind of going further into detail about at the bottom of page 13, but this idea of describing your distribution. All right. Four components when it comes to describing distributions. You need to know your shape. You need to talk about the outlier or any potential outliers. You need to talk about the center, and you need your variability or spread, SOC V. And of course, when you're doing all of this, you need to make sure that you include context, talking about, well, what is this data referring to? Now, again, when you're describing your distribution, all right, you need to be as, I'm going to say detailed as possible, but you need to provide as much detail as you can. All right. And when it comes to these readers of your descriptions, what they typically like is that they want you to use descriptive, what I call LY words. So words like roughly, approximately, and so on and so forth. Because when you're talking about description, not everything is going to be exactly perfect. All right. So if you're saying like the shape is roughly symmetrical, that's okay to say. It's not going to probably be ideally symmetrical, but it's kind of giving that shape. All right. So that's why we say use those LY words. All right. So because we just did a lot in this lesson here, I'm going to challenge you all to look at this check for understanding at the bottom of page 14. You have a problem here where we're looking at the University of Michigan football team from 1997, and you have a dot plot here that shows how many points that team scored in all their 12 games from that season. So you have 12 dots. So there are 5 parts to this question here. So I want you to take time and see if you can answer these questions here. So pause the video, and then when I come back, I'm going to actually have all the answers ready and available for you. So go ahead and pause it at this time. All right, we're back now. And so here are my answers for the check for understanding. So for part A, we had to create a stem plot based on the dot plot that is provided for us here at the top. All right, so as you can see, we have numbers that go from our tens all the way up to our 30s. So for that reason, my stems for my stem and leaf plot, I'm going to have a 1, a 2, and a 3. And that's to represent we are going to have numbers in the 10s, in the 20s, and in the 30s. We only had one dot in the 10s, and that was at 14. So that's why we have a leaf here of 4. Then we had a couple of games where we had a game of 20, 21, a couple of games of 23, so on and so forth. So I'm going to create leaves to represent all of that. So this here represents 20, 21, 23, 23 again, 24, 26, 27, 28. And then lastly, we have these last three dots here in the 30s. So my stem is 3, and my leaves would be 4, 7, and 8. And that represents 34, 37, 38. So this is your stem and leaf plot. But again, the key here, you need to include, so I'm going to leave that as a note for you all. Always include this for stem plots. So if you're creating this, it is important that you include a key for a reader. And note here, I included context. So when we said 2, 3, that's your stem, that's your leaf, that means 23. Our context here is points. So that's why I wrote 23 points. All right, part B, describe the shape of your distribution. Well, kind of looking up here, well, if we tried to create, like a shape kind of similar to like up here, I'm gonna see if I can do my best here. So, and then we got a little bit of a hump here, and then we go back down. Note here that, well, we kind of have this symmetric shape taking place. All right, so for our shape, we're going to say roughly, see how I use that ly word? We're saying this is roughly symmetric because we're close to the middle as well. Not perfect, but close enough. Now for part C is asking, do we think that the mean, the median would be greater than, less than one another, or equal to? I leave that up to you to decide. It's just, I want you to take a guess there. All right, we're going to talk more into detail about, again, how you calculate those or how you can easily identify that in the next lesson. So don't worry about that. For part D, we're asking, are there any potential outliers? So if we look at our graph here and we see, well, we got a lot of our points maybe in the center here, right around 20 to 28. So we could say, oh, we got this dot here all the way on the left at 14. That could be a potential outlier. Or we might have these 3 numbers here at the very far right, 34, 37, 38. Those all might be outliers as well. Right now, we're not going to worry about that, but eventually in the next lesson as well, we're going to be talking about how there is a rule for finding that. So when we meet again next Monday, I will actually show you how you can identify outliers or not in your data. All right. Now, part E is asking, for the measure of center, should we use the mean or the median? Well, because we have a roughly symmetric shape for our distribution, that means that based on our notes from page 13, we're going to go with the mean. So remember, if it's symmetric, go with the mean. If we see that it's skewed, then your measure of center should be the median. All right. Whew. I went through a lot in this presentation or in this video, and I get it. This was not something that I anticipated us kind of having to go through, and I appreciate you all kind of bearing with me in this process. All right, so as we kind of get to the end of this video, there's some things that I do want to point out, just so you are all fully aware as well. So I'm going to share my screen one final time. Actually, give me 1 second. Okay, here we go. All right, so here we are. I'm on Blackboard. I'm going to use, no offense, period 2. I love you all. I'm going to use period 1 because I think I put in here in period 1. All right, so as you can see in lesson videos, this video that I recorded will be posted here. So if you need to refer back to it at any point, this is how you find it in Blackboard. So this will be here later on this evening. In the Scholar assignment folders under the Unit 1 section, you will see that not only will there be the three homeworks up to today that we have already looked at, the Lesson 4 homework will be available for you all starting tomorrow. And that will be due on Monday at midnight. So Monday, when we meet again, that's when Lesson 4 is due. Not only that, but under the assessment folder, you will see that there is a quiz here that is going over lessons 1 through 3. So everything that we talked about from Friday to Monday the 10th. So that is what we're going to be quizzed on in here. This is going for a formative grade and it is timed. So you need to make sure you're careful about that. So once you open it, you need to make sure you give yourself 60 minutes to work on this quiz. So if you feel like you're going to have to take a break in between, I would say just find a time in which you could just take an hour for yourself. I don't think you need the full hour for it, but just make sure you have that time available. All right. Um, Now, hold up. All right. Um, Dang, I just realized I don't know if you guys were able to hear me. Testing, testing. Anyway, oh well. But yeah, just keep in mind that this here is also due on Monday at midnight. So please make sure you set some time aside to get that done. And again, when I see you all, you should have all of those four homework assignments done alongside this. All right. Now, I do have office hours for the rest of the week, so feel free to come by at any point after school. I know I say office hours, I mean tutorial. But otherwise, if you don't have any other questions, thank you all again for being patient and going through this together. Have a great rest of your week, and I'll look forward to seeing you all next time in class.